Alrighty, so I want to go ahead and solve well, this is actually an appraisal thing that we did before, just to give you some more example problems for those of you that are going to be reappraising on standards. So let's get this slide here. And one. So, we're going to draw some free body diagrams here. So ball's tossed upwards into the air before it has left the thrower's hand, and it's speeding up. Speeding up means forces are unbalanced. So I'm going to have the force of the hand going up, but I'm also going to have the force of gravity downwards, and this arrow does need to be bigger. Next, we're going to have a person on an elevator moving upwards at decreasing velocity. So that means it's slowing down, and that means the gravity force is going to overpower the normal force pushing upwards on the person. So Fg needs to be just a little bit bigger. And finally, we have a glass being pushed on a table at constant velocity. Well, that means we're going to end up having a normal and a weight, which is fine. But then the other thing is we've got a pushing force, Fp, and that's going to exactly balance the friction force. That's why it moves at constant velocity. If you just drew the pushing force, it would accelerate. So that's problem number 1. I'm going to try to do this again. This is problem number 2. So the forces do not balance, and so what that means is we're going to have the up forces, A and D, and they're going to compete with the down forces, which are E, B, and C. And the effect of these two competing sets of forces is that the mass accelerates. Next, we have horizontal forces not balancing, and then vertical do. So let's balance the vertical. That's going to be F norm balances F grav. And then in the horizontal direction, since they don't balance, we're going to have the applied force competing with friction, and the effect is that the mass will accelerate in that direction.